Okay, so let's take a few minutes to formalize what you should have seen in your explorations or investigations. Um, the first investigation had you looking at the common log or log base 10, and hopefully what you noticed was that when you took the log of a number that was a power of 10, the answer was whatever that power of 10 was. So for example, the log of 10 was 1. The log of 1,000 should have been 3. The log of 1/100th was -2. Okay, so to formalize, given and function y equals 10 to the x, we define its inverse to be x equals 10 to the y. And up until now, we haven't had a way to solve for y. Okay, and because there isn't really a good way to solve for y, mathematicians defined this to be the log base 10 of x, or more commonly seen, just the log of x. So we use log base 10 so often that we don't usually indicate the base. So if you don't see a base indicated, you know that it's just the common log base 10 of x. It's very similar in the note here. It's very similar to like the square root of x. Okay, that means square root of x is an index of 2. Okay, but we don't indicate that because we use it so much. So we just know that the square root of x implies that there is an index of 2. Okay, so same idea with log base 10. So when you don't see the base, it's implied that it is a 10. Okay, the second investigation had you looking at log base 2. And again, hopefully what you saw when you were taking the log base 2 of powers of 2, so for example, the log base 2 of 4, the answer was whatever power of 2 that was. So the log base 2 of 4 was 2. The log base 2 of 32 is 5. The log base 2 of 1/16 should have been -4. Okay, and so on. So again, given the function y equals 2 to the x, we define its inverse as x equals 2 to the y. So again, we didn't have any specific way to solve for y, so mathematicians defined this to be the log base 2 of x. So y equals log base 2 of x, right? So we can rewrite this x equals 2 to the y as y equals log base 2 of x. So more generally, if we have y equals b to the x, and its inverse is x equals b to the y, mathematicians just defined this in general terms to be y equals log base b of x. And then finally, given y equals e to the x, e being the natural base, okay, if we invert x and y, we get x equals e to the y. That's the inverse. And mathematicians gave this a special name as well, and we call this ln of x. And ln is just the natural log. Okay, so this is called the natural log. Ln is the same as equal as the log base e of x, but we will never write it as the log base e. You'll never see it that way. It's always written as ln of x, natural log of x. So logarithmic and exponential functions, the big idea here is that they are inverses. Okay, so they will undo each other. Okay. All right, so the big definition here is that y equals log base b of x if and only if b to the y equals x. So again, a logarithm is simply an exponent. Okay, it's another way to write an exponent. These two forms are interchangeable, and there'll be one form may be useful over another depending on what it is that we're being asked to find. Okay, so the most important thing to notice is that these two expressions essentially mean the same thing. They're interchangeable. Okay, so they're inverses of each other, they're interchangeable. So let's look at a few examples before you go back to working on your own. Okay, right, log base 3 of 81 equals 4 in exponential form. I'm going to bring this back so we could see. Okay, so log base 3 of 81 is in this form here, log base 3 of 81, where 3 is your b, your base, and 81 is your x, and we want to take that form and rewrite it like this. Okay, so if you want to go with what we have up in our definition, the 4 is like the y, right? The 3 is like the b, and the 81 is like your x. Sorry, that's a little bit messy. That's supposed to be a b. Okay, so we're going to rewrite this in exponential form as 3 to the 4th equals 81. And it should make sense. Like 3 to the 4th is actually 81. Okay, so it should be a true statement. These are equalities. Okay, so I'm telling you log base 3 of 81 equals 4. I might not expect you to know that right off the bat right now, but when you rewrite it in exponential form, you should see that it does make sense. Okay, so now we're going to go backwards and we're going to write 27 to the 2/3 power equals 9 in logarithmic form. And again, you should know that 27 to the 2/3 power is 9. For those of you that don't remember, the 2/3 power is like taking the cube root of 27 and then raising that to the second power. So the cube root of 27 is 3, square that is 9. So we want to rewrite this as a logarithm. Okay, so this, the 27 is like your b, the 2/3 is your y, the 9 is your x. So log base 27 of 9 equals 2/3. Okay, log base 27 of 9 equals 2/3. So the thing to note here is, right, that we call this a base, b, a base raised to an exponent. Well, the log base and the base that we raise to the exponent, those two things are the same thing, right? The log has a base, and then the exponent also has a base. So those two numbers are always the same. Okay, we can also evaluate logs. Right, so the log base 3 of 27, so the question is, what does the log base 3 of 27 equal? So equals what? So sometimes, equals question mark, or you could call it equals y or equals x, just to kind of give you, a substitute, just to substitute something in so that you kind of know what you're solving for. So I'm going to replace that question mark. Let's just replace it with a y, any variable will do here. Right, so when I ask you to evaluate log base 3 of 27, what I'm really asking is 3 to what power equals 27? And hopefully you can see that y equals 3 here. If you don't, you can go back to how we solved exponential equations prior to yesterday's quiz, where we would rewrite this 27 as 3 to the 3rd power. So 3 to the y equals 3 to the 3rd, and y must be 3. So that's another way to think of it as well. All right, so same thing over here, log base 4 of 64, that equals some number. Let's call that number x this time. So 4 to the x power equals 1/64. All right, so now we've got to think about this. If we have 4 raised to a power, and we get a fraction, that power must be negative. So this is x equal to -3. And then finally, these are some simple logarithmic equations. It's actually no different than what we were doing in C and D. So solve log base 7 of x equals 3. We're just going to rewrite it as an exponential. So this becomes 7 to the 3rd equals x, and then we evaluate 7 to the 3rd, and we get 343. And then finally, log base x of 8 equals -3. So x to to the negative third equals 8, and then we have to think to ourselves, okay, well, what to the negative third power is going to give us 8, and that's a little bit tricky. But if we know our powers, we know that if x equals 1/2, and we raise 1/2 to the negative third power, we will get 8. All right, you can go on and continue to practice with the similar problems on the rest of this packet, and then next class we will kind of go over any questions that there might be and kind of discover some inherent properties of logs as well.